Hey guys, today we're going to talk about using coordinates to prove simple geometric theorems algebraically. So we're going to prove different types of shapes on graphs using their coordinates. So my first question says, 3 students are playing a game and their starting positions are shown on the coordinate plane below. So here's a picture, here's my starting places for the 3 people. A 4th student is joining the game and will be starting in position K. What should the y coordinate of position K be to make HIJK a parallelogram? Now, I know that a parallelogram has 2 sides that are parallel, and it also has 2 sides that are congruent and have the same slope. So that's really important. So whatever the slope is for these 3 points, my 4th point has to retain that same slope as I'm looking at my sides that are parallel to one another. So if I'm taking a look at this graph here, I see that from I to H, this is going to be where my parallelogram is connected. And whatever the slope is here, I want to make sure that I have the same slope up above. So my slope looks like I go down 2 and then to the right 2. So I'm going to do the same thing with point J. I'm going to go down 2 to the right 2. So in theory, it looks like my point K should be right here. And then I can connect and it should make a parallelogram, but I do need to check just to be sure. So the first thing I'm going to do is make sure that these 2 sides that are parallel to each other are also congruent. So my distance for J to I is 1, 2, 3, 4, 5 units. And then my distance for K to H is 1, 2, 3, 4, 5. So it looks like both of these sides are congruent and parallel. They both have an undefined slope, right? They're vertical angles. That's good. And now I just have to check for these 2. Now, I could check their distances, or I can just straight up go and look through both of them and do the, just find their slopes to make sure that the slope is the same. So I'm going to find the slope of JK, and then I'll also find the slope of IH, just to be positive. So to find slope, I'm going to take the change of y over the change of x, right? And so I'm going to write the coordinates. Point J is at 1, 4, K is at 3, 2, H is 3, -3, and I is 1, -1. And so just by looking at the picture, I can pretty much tell that they're a parallelogram, but I do just have to check to be sure. So my change in y from J to K, so y values are second. To go from 4 to 2, I subtract 2. And to go from 1 to 3, I add 2. So my slope is -1. I'm also going to find my slope from I to H, make sure it's okay. Change of y over change of x. So my y values to go from -1 to -3, I subtract 2. And to go from 1 to 3, I add 2. And my slope is -1. So it looks like that point K is at the right spot. So the question asks me, what's the y coordinate of point K? So point K is at 3, 2. So the y coordinate is at 2. Next question. A top view of downtown Rockford is shown on the grid below, with Granite Park represented by quadrilateral A, B, C, D, which is down here. The shape of the new park, Mica Park, will be similar to the shape of Granite Park. Vertices L and M will be plotted on the grid to form quadrilateral JKLM, representing Mica Park. So here's my first picture. I'm going to have a similar one over here, and similar means same shape, different size. Which of the following coordinates for L and M could be vertices of JKLM so that the shape of Mica Park is similar to the shape of Granite Park? So Granite Park is given to me in the form A, B, C, D. That means it'll be similar to the one that's given to me here, which is JKLM. So the corresponding pieces are going to be in order. A matches with J, B with K, so on and so forth. And that's really important as I'm going through. Now, first thing I want to do is just look for some corresponding sides here to find, so I can find a ratio of one piece to the other piece. If I look, I'm given points A and B, which are the first 2, And then I'm also given point J and K. So that means if I find the ratio of these two, then it's going to be the ratio for all of my points. So what I could do is find the distance between A and B, and then the distance between J and K using the distance formula, or I can just kind of count. This is 1, 2, 3 diagonals, and this is just one diagonal. So my ratio for big to smaller from this big granite park to mica park is a 3-to-1 ratio. So 3 divided by 1. So as I go to plot my new points, they have to be in the same ratio of 3-to-1. If they're not, then it's not the right answer. So what we're going to do is I'm just going to take the points, I'm going to plot them, and I'm going to see if they give me a ratio of 3-to-1. So my first point is at 4, 4, and then 4, 3. So that's L, and that's M. Okay, and so I just need to make sure and see if my corresponding sides are in the same position. So this is first problem letter A. Okay, so I already know that it needs to be a 3-to-1 ratio, so I need to figure out if this side's a 3-to-1 ratio, and then if it matches up, same with the other ones. So I see just by looking at the problem here that CD will match up with LM. So when I divide those two numbers, right, their distances, I should get 3-to-1. So CD, C to D, has a distance of 1, 2, 3. LM has a distance of 1. Okay, that looks like that works so far. Let's try the next one. BC looks like it is matching with KL. So B to C is 1, 2, 3. K to L is 1, 2, 3. Oh, that does not look like a 3-to-1 ratio. That is not right. So that tells me that A is not the right answer. Okay, so I'm going to erase my letters here and plot the next points, and so on and so forth. So you actually don't even really need to plot the points, but if you like to plot, you are welcome to do so. So my next one is 7, 1 is L, and then 6, 1 is my M. So now we'll see if that's the same. Again, I'm going to do the exact same thing, and maybe I'll do it down here, A, B, C, D, so that I have a little bit more room. Again, 3-to-1 ratio. Okay, so I'm just going to start again by finding some sides that match up. So C and D match with L and M. So let's see if it works. C to D is 1, 2, 3. L to M is 1. That looks like it works. I have to still do B to C, and that would correspond with K and L. So B to C is 1, 2, 3. K to L is 1, 2, 3. Whoops, okay, that's not a 3-to-1 ratio. Doesn't work, so already I know B is not my answer. Now I've got a 50-50 chance. Let's finish up and see if it's the next one. So letter C is at 7, 6, 4, 5, 6. And then M is at 6, 6. Okay. All right, same thing. I'm going to rewrite A, B, C, D, J, K, L, M. Okay, so notice that these are not changing, like what parts are matching, but what is changing is just my numbers each time. So the first one is CD matches with LM. So CD hasn't changed, it's still 3. LM is 1. So, yep, that one looks like it works. Next one is BC matches up with KL. Okay, if I go back to my picture here, BC still hasn't changed, it's 3. KL is 1, 2, whoops, nope, doesn't look like that one works either. That's not a 3-to-1 ratio, so I know C is wrong. Well, that means it just leaves me with answer D has to be my answer, but I am going to just plot the points just to be sure that that is correct. So 8, 4 is L, and then 8, 3 is M. Okay, and we'll do the same thing here with my little picture. I'm going to write my proportions and see if they're the same, but they should be. So CD, if I look at my picture, is 1, 2, 3. LM is 1. So that one works. And then the last one is BC and KL, are they the same as well? So BC hasn't changed, it's still 3. KL to DA is just 1. So this problem has a ratio of 3 to 1. So because all those points are a 3-to-1 ratio, my final answer is letter D. So notice that it's very helpful to definitely draw on the picture. Okay, hopefully this helped you out. Now you can stop the video and try the practice problems.